Okay, now we are discussing the Heisenberg's uncertainty principle. What is that? Heisenberg's uncertainty principle. So, it is a consequence of dual behavior of matter and radiation. It is mainly the consequence of dual behavior of matter and radiation. So, why this Heisenberg's uncertainty principle is proposed by Heisenberg? So, because you know that electron is a very light particle. Electron is very light particle. So when we are giving some amount of light, so some amount of light with a shorter wavelength or higher wavelength, shorter wavelength or higher energy. So while we are focus some amount of the light on the electron, smaller particle, so there you may see that change in the position and as well as velocity. There you can see the position as well as velocity or momentum. So to relate that both position and momentum or velocity, so he has given one principle. What is that? Heisenberg's uncertainty principle. He said that it is impossible to determine. It is impossible to determine simultaneously the position and the exact momentum. So it is impossible to determine the simultaneously the exact position and the exact momentum or velocity of subatomic particles. So what is saying that it is impossible to determine simultaneously the position and the momentum or velocity of subatomic particles like electron. So what is the reason for that? Suppose if delta x, suppose you see the formula he has given that delta x is equal to delta x delta b is greater than or equal to h by 4 pi. So delta x delta b is greater than or equal to h by 4 pi m, h by 4 pi m, or delta s delta b is greater than or equal to h cross by 2 pi m, h cross by 2, h cross is equal to h by 2 pi. So if the position of the particle is known exactly, if the position of the particle is known exactly, delta x is 0, then delta v will become infinity. So what is happening in the velocity? Suppose if you know the position exactly where it is, by applying the some frequency containing light, so at the time what will happen? The subatomic particles take the energy and moves to from lower energy level to higher energy level. Yes or no? So at that time, if you know the, for example, position is exactly known, that velocity will become infinite. Suppose if velocity is known exactly, then position will become infinity. Is it clear? So for that he said that it is impossible to determine simultaneously. Simultaneously we cannot determine the both position and the momentum. Both position and momentum or velocity of subatomic particles like electron. That is Heisenberg's uncertainty principle. That is delta x, delta p, delta x the uncertainty in the position, delta p is the uncertainty in momentum, h by 4 pi. So that is delta x, delta p is, you know that p is the momentum product of mass and velocity. Is it clear? So mass of the particle and velocity. So delta v is greater than or equal to h cross by 2 pi m. That is h cross is equal to h by 2 pi. So now we see the significance of uncertainty principle. So what is the main significance or importance of uncertainty principle? So it rules out the definite path of electrons. So actually Bohr told that electron revolves in a circular path we call orbit. But what we are saying here, the position according to the Bohr, if the electron revolves in a particular orbit, you can say that so and so electron is present in the particular orbit. So there is a position. Like that we may explain. But by observing the uncertainty principle, there is no chance for the definite path of the electrons in the atom. There is no existence of the path. Suppose if paths are there, we may identify identify the positional momentum. But that Heisenberg's uncertainty principle said that there is no circular paths or definite paths for electrons. Is it clear? And it is only applicable. It is only applicable for the microparticles, not macroparticles. Suppose if any light falls on that material, it has to change its motion. It has to change its velocity. Yes or no? If the particle does not change the velocity, the Heisenberg uncertainty principle will not work out. So it rules out the definite path of electrons, unless it is only applicable for the microparticles, not macroparticles. So these are the main applications of the significance or importance of the Heisenberg's uncertainty principle.